Hi, this session regarding to the time complexity which is calculated for different conditions like looping statements, constant time statements, nested looping statements, sequence of statements, and conditional statements. First, we will see how and which are the contexts will consume constant time during the execution. The constant time is indicated by order of 1. Then, for the order of 1, time is consumed for assignment operation for simple data types and any arithmetic operation. Here, for multiplication 1 unit of time, order of 1 time will be consumed, and for addition another order of 1 time, and for subtraction another order of 1 time. For assignment, again order of 1 time will consumed. Totally here the 4 units of time, 4 units of time will be consumed. So this is also constant time. Then array referencing. Here we are declaring the variable alphabet using the array. The data type is character. Here we are referencing the alphabet, the variable character variable, I mean array variable, by returning the location 2, right? So here the alphabet is the variable, array variable used as a reference. So this also consumes order of 1 time or constant time. Then array assignment. So here for all j, I mean a of j may be from 0 to n, a of 0, a of 1, a of 2, a of 3, any values. So you can assign the value to the array variable, which also consumes order of constant time. Then conditional tests, which is just testing, that means relational operation inside the if statement or while statement, like that. So this conditional test also, which is giving either true or false, which is also consuming constant of time. Then analyzing the looping statements for loop. Here which is having two portions. One is how many iterations are performed in the looping statements. How many iterations are performed in looping statements, and how many primitive operations per iteration is carry on. Here how many primitive operations here inside the for loop and also inside the looping statement, how many primitive operations are carried out for each iteration. So this we have to identify. For example, here we are declaring the integer variable sum with assigning the value 0 and one more integer variable j. Here this will consume order of constant time. Then inside the for loop initialization, which is also consuming order of constant time 1. Then here which statement is comparison statement, which is also consuming order of 1, but n times it will execute. Here also incrementation also will perform for n times. Then this addition will perform for n times, assignment also perform for n times. So here we are getting 4n plus 2. So order of 4n plus 2. So here the loop will execute from 0 to n, that means n. Then 4 operations, that's what we are getting here. four operations are performing. That's what I told you, 4n. Four operations are performing inside the iteration. Inside the iteration. So for each step which is consuming order of one time, right? So 4n, n times, which is performing n times for each iteration. This is for each iteration. Then n number of iterations will be performed, so n times. So here it will be calculated, then lower order term can be ignored, coefficient also can be ignored, so we can get order of n is the time complexity for this example. Then one more thing here, suppose if you are getting 100 is the condition, so what will be the time complexity? Here we have given earlier n. If it is the n, our time complexity is big O of n. If it is the 100, then our time complexity will be order of 100. Order of 100. Here we are using the while loop. In the while loop, here your I is assigned with 1, which is performing for one time, executed for one time, then I less than n. So here I is compared until n comparisons, so n times it will be executed. Then number of statements, any number of statements, so these statements will have c, constant number of statements. Okay, for example, c equal to 3, so 3 number of statements may be available. Then I plus plus, which is, so this 3 number of statements will be executed for n minus 1 time, because here comparison is performing for I less than n. So when n is 5, then it will check until 4 less than 5, 4 less than 5. When 5 less than 5, automatically the condition will false. So here the it will check until n minus 1 time. So this block will execute for n minus 1 times. So here n number, c number of statements, then execute for n minus 1 time. So that's what given here. Then this increment statement also will execute for n minus 1 time. So here this is 1 time, then this will compare for n times. This c number of statements for running for n minus 1 times, this is also run for n minus 1 time. So now we have to add all the statements run time. So here this is I equal to 1, first this runtime, then n minus 1. This n minus 1 is that means executed this comparisons n minus, actually n comparisons also we can have it, otherwise n minus 1 comparison, because which is executed for 4 less than 5 and 5 less than 5 less than 5 means the condition is false. Then c number of statements executed for n minus 1 time, then I increment I plus plus executed for n minus 1 times. So when you are substituting these values, you will get c into n minus 1, this n minus 1 and this n minus 1, 2 times of n minus 1 you are getting, then plus 1. Finally you will get constant c plus 2 into n minus 1 plus 1. So c plus 2 into n minus c plus 2, we are multiplying this. Okay, c plus 2 then into n minus 1. So here we are calculating this c plus 2 into n minus c plus 2. So that is the statement given here. Then here this is lower order term, we can ignore it. The n term is the time complexity, which is coefficient, so we can ignore this. So finally we are getting order of n. Next one, nested loops. Here you look at this, we are having one for loop which is running for n times, and inside that we are having one more for loop which is also run for n times 4. So here for each j value, this for loop will run for n times. So here we will get n number of iterations for each j value, each j value in the inner loop. That is the case. So need to evaluate inner loop for each iteration of j value. So we will get inner loop also will run for order of n time. Here this is for each j value inner loop will run for n time. So we will get order of n into n, order of n square. So for each j value it will run for n times. So this is j is moving from 0 to n minus 1, that means n times, then n into n square. Simply we can calculate. And one more nested loops here, same thing we have given. So here j is 0, which is running for n times. Then this is for each j value, k value run for n times, n into n we will get n square. So for summation of n numbers, the time complexity will be order of n square, right? Now in big O analysis, sometimes we will compute the series like sum of first n numbers. So the formula for sum of first n numbers can be given n into n plus 1 by 2. So here summation of n numbers, I value is 1 to n. I value is 1 to n, summation of n numbers. The formula is n into n plus 1. When you are multiplying n into n square, you will get the n. Here finally we will get n square by 2 plus n by 2. Here this is lower order term we are ignoring. Then this is the denominator is the constant, so we are ignoring. So finally we are getting order of n square. Then sequence of statements. Suppose if we are having the sequence of statements, how do we calculate the time complexity by using asymptotic notations? Here first one, for loop index is j, it is moving from 0 to n minus 1, that means which is running for n times. Then for loop again k, so k is run for each j value, this for loop will run for n times. So this n into n square, right? So until this it will run for n square, right? So order of n square. Then next for this is next sequence of statements for loop. Here l is the 0 which is l less than n minus 1, that means which is also run for n times, which is also run for n times. So this for loop will run for n times. That's what mentioned here, order of n. Then system.out.print statement will run for only one time, so order of 1. Now this program is having sequence of statements. We have to calculate all the time complexity by adding it. So order of n square plus order of n plus order of 1. Here order of 1 is the lower order term, order of n also lower order term. So finally we are ignoring this lower order terms, we are using the higher order term, order of n square. Then conditional statements. If condition which is having the some relational operation, if this condition is true, this statement one block will execute. If the condition is false, this else block will execute statement 2. So where statement 1 runs in order of n time and statement 2 also run for order of n time, uh, based upon the condition here, based upon the condition here. That, but sometimes if you are using the for loop before if condition, based on this condition it will run for n times. But when condition is false or true, for example I am taking n is the 7, so 7 times if condition will execute, but in this 7 times 4 times maybe true statement will execute, 3 times maybe false statements execute. So here the true block will take more time and false block is consuming less time. So here we have to take upper bound. So upper bound is 4. So like this we have to take upper bound the worst case complexity. So maximum time consumed between sequence 1, that means statements 1 and statements 2, sequence 2. Okay, the time consumed between, maximum time consumed between sequence 1 of statements or sequence 2 of statements will be considered as the time here. So finally we will get any one of order of n time. That is the thing. Then this example explains the recursion equation, recurrence relation. Here the function will call by itself for n times. Look at this. The double is the data type, method name power. Here two arguments x and n. So x is the base value, n is the exponent value. Here we are taking some n equal to 2, n equal to 2. So if n equal to 0, return 1, otherwise, right, otherwise we will have some number of statements. Then finally return power of x comma n minus 1. Here n equal to 2, so initially we are passing power of x value you can take some 3 and n value is 2. Then you are returning this statement, power of 3 comma 2 minus 1, 1 into 3. Then again it will go back. Now n value is 1, n value is 1, so n equal to 0, return 1. So this is false. Then it will return power of 3 is the x value, n minus 1, n is the 1, so 1 minus 1, 0 into 3. So now we are having one more value. Then n is 0 now. Now 0 is passing here. N equal to 0, return 1. Return 1. So it will return 1 now. Right? So this power of 3 comma 0. So now you go back. Right? So power of 3 comma 0 now. Power of 3 comma 0 is 1. Power of 3 comma 0 is 1. So 1 is substituted here. 1 into 3, 3. So now this value become 3. So 3 into 3, 9. So 9 is the value substituted for power of 3. Okay, 9 is given. So 9 is your value. You look at here, in this location the running time is calculated. This will consume, right, some constant value. That's what, if n equal to 1, if n equal to 1, then the t of n, that is running time, is only 2, because if n equal to 1, this statement will execute, which is false, then return. So here the x comma 1. Okay, then 1 minus 1, again 2 times it will execute, right, 2 times it is executing. So constant, the value is constant if it is the 1, right, right. Then if n greater than or equal to 2, if n greater than or equal to 2, then the number of steps taken, you look at here, this n equal to 1, if n equal to 1, 2 times this one and this one, okay, 2 plus t into n minus 1, right? We are this value, okay, t into n minus 1. So here finally what we will get, this is again and again we have to perform for all the n values by reducing one by one. So it can be done by using the iteration method. Otherwise, one more method is recurrence relation method is there by using the master theorem. So we can use for calculating the time complexity for recurrence relation. And here how we are using the asymptotic notations um, for calculating the three cases. One is the worst case, and the worst case is mostly used because the worst case algorithm is denoted by big O notation. Big O notation. So this big O notation is used to represent the upper bound of algorithms running time. Upper bound in the sense maximum time which is consumed by the algorithm. For example, if you take array of numbers, so array is having 8 elements. In this 8 elements, I am searching the value 95 which is existing or not, one by one. I will search from starting index to ending index one by one, so which is called linear searching. I am searching the element in the given array linearly. So what will be the worst case time complexity? That means maximum time consumed by the algorithm. So when you are searching the 95, you just look at here, 14 is not equal to 95, so then move to the next index. 2 is not equal to 95, move to the next index, likewise until last index 95 is not available. When 95 is not available, here for each step we are consuming 1 unit of time. Here 1 unit, here 1 unit, here 1 unit, until here 1 unit. When you are calculating this, for n number of values, 8 number of values, we are consuming 8 units of time. 8 units of time. When you are adding this all the time, you will get 8 units of time is consumed. Our input also 8. So from this we can observe, for n input values, the time is consumed order of n. Time is maximum time is consumed order of n. So this is the worst case. Worst case means it checked all the elements in the given array to search the given element is available or not available. So if the element is not available, then worst case time complexity is maximum time consumed by the algorithm. In this case, the n number of elements are checked in the given array, so which is consuming order of n time. Second one, average case analysis. Here, this will be used rarely. So here it will take all the possible inputs and calculate the computing time for all the inputs. Here it will check all the elements and computation time. It will sum it. It will sum it. After sum all the calculated values, then divide that sum by total number of inputs. Sum divided by n. Sum divided by n. And one more condition is we should consider the distribution of numbers, distribution case. We have to consider the distribution case, like numbers are distributed randomly, numbers are distributed uniformly, like that. So here you look at that index, we are distributed, right, linearly, sequentially, right. In linear search, assume all the cases are uniformly distributed, uniformly distributed. Even x is not, I mean, given number is not present in the array. Not present in the array. So we will sum all the cases. So first we will search the first index. It is consumed by some time. Then second index, third index, like that we have to calculate for all the n numbers, then divide that sum by n plus 1. We are averaging. Okay, we are averaging. Why we are dividing? We are calculating the average. Okay, for calculating the average, we are sum by n plus 1. So here this is represented by using sum of I equal to 1 to n plus 1, because that element is available or not, we will search that. So n plus 1, so which is represented by I. So finally you look at that, we are starting from 1 to n plus 1. 1 to n plus 1, this is sum of numbers from 1 to n plus 1. Sum of numbers 1 to n equivalent to n into n plus 1, n into n plus 1 divided by 2. If n is n plus 1, this n is, right, this is for n numbers. Okay, sum of n numbers, but here we are using the sum of n plus 1 number. So we are substituting here n plus 1 and n plus 1 for this n plus 1. So we will get n plus 1, n plus 2. So this is what given here. So n plus 1 into n plus 2 divided by 2. Okay, this is denoted by big theta, because we are going to calculate average. We are going to calculate average, right? So when you are performing this, you will get order big theta of n square plus 2n plus 2 divided by 2 by n plus 1. Okay, so here you can remove the higher order lower order term. Here you can remove this one, otherwise here you can remove. So here also you can remove order, I mean lower order term. So finally you will get the big theta of n square divided by n. So when you are removing this, right, you will get big theta of n. So that's what given here. Okay, so this is the way to calculate the average case. Average case, we will use sum of all the time consumption divided by n plus 1 number of inputs. Then best case is very rarely used, that is minimum time consumed by the algorithm, which is representing the lower bound. So the minimum time, when, so my target element is 14, you look at that minimum time is the searching element, the expected element is available in the first index itself, so which is consuming order of 1. Suppose my element is available in the second index, so which is taking order of 2. This again it is a constant. If it is a constant means that again it will be, it can be say order of 1. So that is the thing, minimum time consumed by any algorithm is the order of 1. For example, in the linear search, our searching element is available in the first index itself. So with this I conclude this session. Thank you.